Alright, I am sorry about that little glitch. My device wasn't working. Okay, so ever since computers were started, people started recording and saving data. The traditional computers, when before the advent of databases, in a regular folder, people would go ahead and start creating those files. Suppose they want to record some stock of the elements that they have, they would go ahead and make those entries in this particular file or in a specific location on their computer. The only problem with this thing is that when you lose track of this thing and items and elements are supposed to have some interconnection, those interconnections they were not always guaranteed. Like this table here, for example, is for stock of some element, and this is probably for the invoices or the billing that you want to generate for those things. The problem here is when you are manually storing these files like this, if you have like 10 cars in the inventory and you want to sell them off, you would want to generate an invoice for those 10 cars only. But then if your invoice, because there is no because this data is manually entered, there is no connection between what you have in stock and what for what kind of item you want to generate invoices. And then if this document here mentions that you have 20 cars in the stock, the invoice that you're going to generate is going to be for 20 cars, for example. And then people were bothered about this problem already, but then it took set theory. If you remember these Venn diagrams and these Venn diagrams where we drew the finite set that we have, and then how these elements or how these groups of data they would want to be interacted and overlapped. It was when the set theory got started applying to the creation of databases. This is when databases evolved to what we know today. It was a scientist at IBM, a researcher at IBM, Dr. Cod, who started applying set theory for storing data. And Dr. Cod came up with about 13 rules. And then these 13 rules became what is the foundation of today, what we call the relational database. As databases grew more mature, people started adding more and more rules to this original list of 13, and there are about 200 rules that contribute to the modern relational database set theory. With that said, in databases, what we try is we try to store entities. Now, an entity could be an item. So suppose um, this is a this is a screw, and then this screw is going to have a certain size. So somebody who is in the manufacturing of this thing of these screws and nuts and bolts, uh, they would be interested in knowing what is this variable here, what is the length, and what is the distance between these individual pitches. So this is something that they would want to store, and it would become the size, the length, and the size of pitches. And they are going to store this information in their databases, and probably they would also want to store the count of this information that they have. Now, entities like this, they become very interesting. If you are into manufacturing of this particular product, you would want to keep track of what size element you are manufacturing. So if you have 100 of these and then you manufacture another batch and then you have 50 of these, and then somebody manufactures another batch of the same size as the first one, you would not want to make a new entry for that. You would probably want to go back and update this particular record set here to 150. And then the information that we track, like the size, the length, and the pitch and the count, they are called the attributes. Now, there are two types of attributes. One attribute that uh, identifies the item or provides the quality of that particular item. But then a combination of these particular attributes like 1, 1, and 2, it becomes what we call today the primary key. Now, the reason primary keys are important, sorry, just one second. All right. So the reason primary key is important because you don't want to run into issues where you are updating, you are making duplicate entries for a unique item. And this is one of the core rules that databases or the way you are storing information, it should provide you some mechanism of identifying a unique entity inside your data structure. Because a size of one, length of one, and a pitch of two is a unique item in this particular product, and you would want to track it differently when it comes to storage. You would want to have exact quantity, and then this exact quantity is going to help you have better control over these things. With that, we are going to come to one of the second laws of this. So this is the primary key. The second one is about English-like sentences. So storage is fine. I mean, with this, probably we resolved how we would want to store this information. But when it comes to extracting this information out of the tables that we have, we would want to have a special language for this thing. And in that language it's going to tell what information you would want. So if you want the size, you would say, give me the size of the nuts that we have, and uh, they are stored in a file called, say, nuts and bolts. And uh, I would only want where the uh, where the head size is one, where the length is one, and where the pitches are two. So you are essentially going to provide the information as to what fields, what attributes you are interested in. If you want X and Y and Z and count, you are going to tell that. You are also going to tell the location as to where to find that information, in which file, in which folder, at which spot. And then you are going to provide a filter criteria, and then using this filter criteria, the information in this particular structure is going to get picked up by a system called DBMS. So database management system is going to take English-like sentences, and using these English-like sentences, it is going to connect to this particular data store, and it is going to give you data. This English-like language initially was at the time in 1970s, it was called Square, which later on evolved to SQL, uh, English-like language. Uh, I'm forgetting the full form of it, but then it is query expression language something, and then it evolved to the modern day programming language or database language, which is called SQL. All right, this is not called SQL. It is pronounced three separate letters, SQL. Now, now there are two type of programming languages that are, or there are multiple ways of programming. The traditional way that we have is that we give instructions like print something on the screen. What we saw in the JavaScript class is console.log is going to do something. You have while loops inside this type of programming, wherein you're going to tell exactly how you would want the operation to be done. SQL is a little different. They fall in the category of declarative application. So declarative, I wish autocorrect was there. These are declarative kind of languages. What you do is you just tell them what you need. I want X and Y and Z, and I want it from this particular file, and I want only size 1, 1, and 2. When you create this English-like structure and you pass it to DBMS, it is going to do something in the back end, and it is going to come back with the data that should come out. with this particular query. Okay, so this is one of the difference between programming languages and SQL programming. That SQL programming does not dictate, does not um, provide instructions as to how to retrieve that information. It just tells what information you need. The reason it is done this way is because one of the objective of creating SQL was that a common computer user should be able to extract out the data that they have saved in different tables. Make sense? So moving on, there are two type of information that we can save in a database. One is the scalar value, and the second is a non-scalar value. Right? Scalar values are something like this. Non-scalar values are a point system like 2, 3, 5, 10. Right? If I have to provide a definition, a discrimination between what these two values are, a scalar value is something that can be sorted. All right. So scalar value is something that can be sorted. Uh, just one second. Shailesh, I'm seeing your video. I don't know if you would want that. Meeting options. All right. So, um, we were talking about scalar values. Scalar values are values that can be sorted. The counterpart is non-scalar values. A non-scalar value is a point-like information, which is difficult to sort. So if we have an x-axis and we have a y-axis, right? 2, 3 probably is going to sit somewhere over here, where x is 2, y is 3 is going to be somewhere over here, 2, 3, and 5, 10 is going to be up here, 5, 10. The the reason scalar values cannot the reason they're called non-scalar value is because you cannot sort these points. So when you move information from say one dimension to two dimension, information starts sorting this information gets tricky. And then as you work more and more with databases, you would realize that you would want to perform operations on these tables, and figuring these out in what order they should be saved or what order the information should be returned or processed is going to be an important is going to be important for creating applications. So while you are building a database solution, make sure that when you run into scalar when you run into non-scalar type of data, you want to separate these two out. You don't want to store them as say point in the string format 2 comma 3. You would rather switch and you would rather switch and save them in two separate columns. So 2 comma 3, 5 comma 10, you break a non-scalar value into its scalar component, and you would want to perform the sorting operation probably on one column. So this is one information that you should keep handy as you are working on database designing. Now, we have used a word called DBMS a couple of times, and uh, my way of explaining this uh, is a little different. What happens is you have when you have information to save, um, I would say the only way that you can save it inside a computer is in different folders and in different set of files that are inside these folders. All right. So as you are saving this information, you would want some mechanism as a consumer, as a somebody as a party who is interested in this information, you would want to connect to these files and do some data exchange. The only problem is that with data being added, there are more and more people who are interested in accessing that particular data. And what that can cause is when you are exchanging data across multiple files, you would want some form of mediator who is sitting between you and the data. And then that system is called DBMS or database management system. Now, once again, our old trick of when you find a big acronym like this, you start reading from right to left. So, a system for managing databases. Okay, a database is any form of storage. A file on your computer is a database. Uh, Something that you are writing in your notepad, they are databases, and something that you are creating through specialized softwares, they are also database. And then those software, they provide you with another solution which is called a database management system. So after this new solution, all these data exchange requests, they are going to get routed through this centralized system. And the reason it does that is because when you are creating data, you're going to have two purposes. One, you would want to protect this data from getting tampered or losing its integrity because multiple people were trying to modify it. And then it would also want to serve your request. So when somebody comes and says that, tell me the nuts and bolts that we are manufacturing, this DBMS system is going to go back into the file storage and it is going to come back with the requested data. So it is some form of control that you would want to execute this data. And the main purpose is protection of this data. You would not want this database to lose its integrity. Okay. With that said, let's do a quick revision of what we saw since morning. So we saw that there are databases, and databases started when people started using computers first. The data initially was stored in file formats, and then we were running into consistency issues. One file can say something else about the data, say for example stock, and the other file can say a different thing about the same information. Because information is disparate, it is difficult to maintain integrity between these things. Dr. Codd applied the set theory from mathematics and started devising solutions that are going to solve this relational problem, and that was the beginning of relational databases, the modern day relation databases. They work on the set theory concepts. When we are storing information, these things they are called entities. Now, entities can have attributes like size, the length, the pitch, and some other information. A combination of these attributes make each entry in these entities unique record. The reason you would want to keep it unique is because this is how you're going to identify or qualify the rows to become unique and perform operations on them. This is one of the Cord's rule. The second Cord rule is that when you're creating such a system, you would want to have an English-like language, and that language is going to be very declarative as against directive. This language is going to look a lot like English, and it'll tell you the information that it wants. It'll tell you where that information is, and it'll tell you how to filter that information. The DBMS, database management system, internally is going to process this instruction, this English sentence, and it is going to perform some operations and fetch the data for you. There are two types of value that you can store. One is a scalar value, and the second is a non-scalar value. A scalar value can be sorted, a non-scalar value cannot be sorted. Um, but and the trick is when you want to store non-scalar values, you would want to divide them in individual columns, and you would want to save it that way. Database management system is different than the database itself. The database is storing these data on your computer, probably in the format of files and folders and as a hierarchy here. A DBMS is the one that controls this folder structure and this file storage. All right. Okay, so this is the beginning or the quick introduction to database management systems. There are multiple things that you can go and look up on the internet, and like Cord's rule and the Square language and the SQL databases. I would urge you to go and read about those things. With that, let's move on to the second topic. Now, I asked you guys to have Docker installed on your computer. So, if I have to explain Docker real quick, let me do that now. So, when, the, so I hope you guys know what virtual machines are. On a host computer, you can install a specific special software, and then that software can simulate your operating system resources or partition your operating system or hardware resources into a specific into a specific allocated size. So suppose if you have 16 GB RAM and you have 8 core processor, a virtual machine can give an illusion that there are only 2 GB RAM and there are only 2 cores available. And then on this particular VM, so this is a host machine, on this particular VM, you can install its own operating system, and then this operating system is going to think that it is a 2 GB 2 core processor operating system. And there are multiple virtual machines that you can create side by side. The reason for doing this is acquiring hardware is a difficult or complex and pricey thing, and it takes time. Virtual machines are something easy. So once you buy a computer, most of the computer time is wasted in switching job and say there is something called a system idle time. If you buy a massive machine and you don't use it to its full potential, you are wasting the hardware resources. Virtualization or VMware, virtualization or virtual machines, it enables you to utilize the full potential of these computers by dividing them into smaller consumable chunks that are generally utilized, say 100%. I mean, this is like the ideal figure. It is going to be less than this, but virtual machine, they have this objective. The only problem is that each virtual machine is going to require its own operating system installation. Linux has a trick and it is called namespaces, that is number one, and something called as control groups, C group. Using these two technologies, without installing a new operating system, Docker platform can help you create these same virtual machine, but then they are all going to share the same operating system. The reason, the way they are going to create that 2 GB 2 core illusion is by using a Linux feature called namespaces and container groups. The advantage of is this, the advantage is that you are not wasting resources by repeating installation of operating system, and they can help you install multiple softwares without much fuss. These are like small files, they are binary files, a specific format, and then once you pull these files from the internet, the installation becomes extremely easy. So if I tell you to install SQL Server, you will have to go to the internet and you will have to find the correct installation for your correct platform. You'll have to go through a huge process and a long process, and then through that process, your dev machine is going to be ready. But then the problem is going to happen when you try to deploy that same code into a production machine or to a QA's machine who is going to test this. Things will work in your computer because you have tweaked it multiple times to get it to working. But then other people who would want to use your code, they are going to have same issues, and you don't want that to happen. And Docker kind of solves that issue. It creates the code as a small binary file, and then this binary file is machine independent. You can take it from one machine to another, and the behavior of the code for which you programmed it, it is guaranteed. It'll definitely work the way it is working on your machine, and deployment cycle is going to become a lot easy. So with this is like the initial theory of Docker. The reason I wanted you to install Docker is because I wanted you to avoid installing these softwares. So what I'm going to do here is I'm going to run a command called docker pull MySQL. Now you can go and install MySQL from internet. Let me pull that. And then there are multiple versions that you're going to see, like community version, the server version, and then through these versions, you would generally have to read through a lot of documentation, a lot of reference material before you can you can start using MySQL. Docker came up with an interesting idea, and they're like, MySQL is going to be pretty standard. It is the data that you would want to save in those databases that is going to make it interesting. So your objective by installing MySQL is not to have expertise in installing MySQL. Your expertise is using this particular database and storing the information that you would want to store. And for that, Docker has provisioned multiple such images which address the technology. So if you want to use MySQL in your project, you would just come to Docker. With the Docker client installed, you're going to run simple commands from this particular machine, from this particular website. It is called Docker Hub, and then this command is going to pull such small binary files, and they are going to be your installation. So installations are going to become extremely easy after you start using Docker. So that is like an added advantage. And I believe that any developer who wants to have any installation done on their computer, they should first consider installing Docker and trying to put that to use, because it makes your job is extremely easy about installations. You don't have to worry too much about what are the dependencies and what other libraries I have to install. With this image, MySQL is guaranteed to work every time. So I'm going to probably copy one of these commands. Just one second. I'm going to paste it here. I'm going to get rid of this. I don't need this. It is saying that when you create MySQL, provided a secret password. I'm going to go easy on myself. I'm going to say uh, minus my secret password is secret123, and I'm going to say that it works on port 3306. I'm going to use this, and you don't have to worry about that right now. Just going to copy this particular command, go to command prompt again, and paste it here like this. Before this, let me see if I have anything running. Okay, so when I run this command, notice that it printed a number on the screen. Let me run this docker ps command one more time. So through this command, it is saying that an image named MySQL has started almost six seconds ago, and then if I use port 3306 on my computer, I'll be connected to port 3306 in this particular little square here, which is representing MySQL in my big host with an operating system on it. The reason I'm going to do this is uh, because I want to have MySQL running on my computer without the hassle of installing that thing. With that, I'm going to launch Visual Studio Code, and through Visual Studio Code, I am going to connect to a database. So this connection here, I don't know if I can disconnect, but then I can call it MySQL demo. This is my local IP. If you remember the password we entered here on the command line, I'm going to enter the same password here, and I'm going to say connect, and hopefully I'll be connected. So over here it is saying success, connect is successful. So I am in the database, and now, okay, so for this thing to get running, I installed an extension and it is called MySQL. So with this thing here installed and enabled, I am able to, it gives you a pop-up here, which is which looks like data disks, hard disks. And then with that, if you come here and then create a new connection, it is going to, on this plus button, it is going to connect you to what is running over here with this particular ID. So these are like quick tips. Pretty straightforward. Run a simple command, install an extension, and when that extension is installed, you're going to see this option. And on this option, you provide it the same port number that you gave in the command and the same password that you gave in the command. And you will have a database system up and running. With this, if you come to MySQL now, you will have an option of writing queries, right? Another option is that you can browse everything that is available in that system over here. This option is a lot easy for a lot of you in the course compared to installing a MySQL server on your computer. So let me pull that real quick on my screen. So I'm launching this SQL Server Management Studio. Now I have SQL Server 2019 Express Edition probably installed on my computer, and that is where we are going to do the rest of our work. But I wanted to show you a different way, an easier way of having your dev machine set up. So SQL Server Management Studio is going to present you with the screen, and it's going to tell you the database server that you want to connect to. Dot indicates my local machine, and I'm connected with my ID here. So I'm going to click on the connect button. Just one second. It's- So I've launched this software, and it is called SSMS SQL Server Management Studio. This is your entry. This is your entry point to SQL Server databases. This is the installation that is running on my machine, and there are multiple options that you can see. The databases that I have on this computer, they are all listed down here, and there are queries that I can write against this particular SQL Server installation. Now, probably I would want to show you this particular drop down here. So there are multiple database name entered here, and depending on how you closed the SQL Server Management Studio or this particular software, it is going to pick up the settings from the last time, right? I have a database available with me for this particular session. I'm gonna choose that particular database, and I'm gonna run our first SQL query, select, and I'm gonna say star from, okay, I don't remember the database name. So what I'm gonna do is I'm gonna run another command. It is called exec sp_help. So when you have table inside your software, there are multiple commands that will help you from SQL Server itself that will help you figure out that topology. So if I run that command, it says that there is something called as car stock. This is a user table, and there is something called as people. That is another user table. So with that, I'm going to hit double hyphen here, and double hyphen comments things out. This is not going to get executed now. If I type select first name from people and hit F5, notice that it is getting first name for me from from the people database. So this is in summary the management studio software for you. There are there are multiple way. So we saw at least three things. One, we would tell them what information we need. Second, we'll tell them where do we need it from, and then next we're going to tell them that first name, that how would you want to filter them. So those English sentences of SQL of the program language, It is available over here, and based on what you are providing in these queries, it is fetching the data for us. Now that is just not it. There are more things that you can do with this particular SSMS tool. Like we have selected the data, we can also insert the data. And then over here I can say my name, and when I enter, it is complaining because it didn't like something about it. Let me just say null. I'm going to hit F5. Okay, so it probably ran two queries, and this is the second part of SSMS that I wanted to show you. When you run queries here, there are two things that you're going to see. One, you're going to see result, and two, you're going to see message of the output of running of that query. So when we do select, it is one row that it fetches from the database, and then when you do insert, it is one row that got inserted in the people database. The output of that thing is going to appear over here, and there is no way that you can close out of this. It does not have a close window. The close button here is only going to close this section. This section is kind of attached to this particular window here. The way to get rid of this is hitting Control R, and it toggles between displaying the message in the result window, probably Control R for result, and it toggles between those things, those two windows. It makes it appear and disappear. Right. So this is a quick overview of the SSMS software. So when you are doing databases or SQL, there are three types of three to three or four types of programming that you can do, and based on the operation, there are different names that are given to this. One is called as data DML, the other is called as DDL, and I think there is also DCL and probably DIL. I am forgetting the fourth one. DCL is definitely there. DML is called data manipulation language. Now, a data manipulation language is a combination of four different type of commands that you can give to the SQL Server. The first command is the select command. The next is insert. Then there is update, and then there is delete. We're going to see all four today. On the DDL side, we have commands that are going to create those databases. So there is something called as create command, there is alter command, and there are a couple more commands, but then we are probably going to restrict ourselves to these two. And then for DCL, I would give you example as we are not going to cover them as part of our session. So inside the select command, we are going to reach out to the database and extract out information from them. So this is where we are going to perform all the read operation. And then these three operations or these three commands are where we are going to modify or affect the data that is there in the system. So let's get started with the select command. I already showed you that you can switch to different databases using this click option. But One of the points that I have been insisting since beginning is that you would not want to use UI as a programmer for the most time. You would want to perform your operations through command line. And another reason that I showed you Docker is because Docker does not make you run in the browser, download binaries and install those. Docker is like command line tool. Through these commands, you can control the installation and running of different applications on your computer. And then as programmers, this is a better way of automation because automating UI is extremely difficult, but then automating commands is very straightforward. And with that, I'm going to show you the first command. It's called the use command. And over here, I'm going to type demodb. Now, if I hit F5 or hit this little execute button, notice what happens to this drop down, right? So this drop down changed here from masterdb to from master to demodb, and that indicates that the database has switched. Now, if I if I want to see what databases I have, I can come to this particular section, hit DemoDB, go to tables, and it is going to show me all the tables that I have. We have two tables at the moment. But if you everything that you are seeing here, they can also be extracted through command line. And the first command that I will show you that I've already shown you is called sp_help. Now, if I hit F5, there are two commands that are going to get executed. The first command and the second command. And you probably won't want that all the time. So one option is that you select the text that you want to run and then you hit F5. So it is only going to run one command. The other option is that you can comment out and hit F5. So I'm going to comment the previous command because my demodb is already in use, and I'm going to hit exec_sp. Now this is an extremely interesting command because it gives you a view into your database. So let me just create some space here, and I don't know if there's a way I can change the font size. Is this too small? Are you guys able to see it? Let me just bump this up to a 12 or a 14. Okay, so it is just increasing this size. Let me apply this first, and then I'm going to go back to this window again. And over here, I'm going to select font, and this time I'm going to apply it to grid result. That is 7, and that's why it was like so small. I'm going to bump that up. Okay, I might have to restart the application, so let's go ahead and do that. I can hit new query here, and notice that it has gone to master. I was hoping that it will stick to the demodb. Now this is switched. Let's go ahead and comment this out. Come down here and type exec. Exec is short for execute. If you want to type the entire command, that is also fine. And then I'm going to type sp help again. And then notice that, okay, so this result appears a little bigger now. So with this, notice that car stock is a user table, people is a user table. There are other objects as well, like queues and primary key. CNS is short for constraint. Then there are internal table, there is default. Probably this is another constraint. Then there are multiple views available here. So all the objects that got created because you wanted to save people information and car stock information, they are all listed down here. And this is what DBMS does for you. It keeps track of all the activities or all the objects in the system for catering to these particular um, requirements. I'm going to copy this command, and execute or exec command has has another parameter that you can pass. And then over here, if I type people, notice the change in output. I just want this particular line to be executed, so I'm going to select that and hit F5, and notice that it is saying that the name of this table is people. It's a user table. The owner is uh, DBO, and the creation time is just last night. Let me scroll this up a little and notice that it has uh, no identity column. There is no ID column. There is a primary key. There is a primary key constraint. And if I keep scrolling down, the default value for favorite color is below blue, and the primary key itself is last name and first name. Now, generally, when you are working in bigger applications, it's a good idea to copy these constraints, and then just for your reference, you would want to tuck them under these table structures so that you can use them at a later point as you are writing more and more queries. I'm going to do the same thing for the other table that we saw, and that table was car stock. And now if I hit F5, I am getting the same information for the car stock table. It is a car stock, it's a user table. It has these 5 columns, and in these 5 columns, it has a primary key, which is the VIN number column. So VIN is vehicle identification number. It's a unique number of a car, of a vehicle. Now, with that, we're going to write our first select query. Select star. I generally have a habit of starting all the SQL keywords on a new line. So select star, then I'm going to move to the new line, and I'm going to type people. This section here, this command here, this selection is going to work just fine. And if I hit F5, we're going to see our result. But a better practice is to provide uh, a namespace for these particular databases. So this is how SQL has structured them. And then if you go to these databases and look inside, the table name actually over here appears like this, dbo.people. So I'm going to provide that dbo option, and I'm going to hit F5. Now see that star is a wildcard, and you would probably want to avoid this thing. This is okay at this point because we are we are testing something. Had it been a production code, something that you would want to use in your client application, in your more serious projects, you would not want to mess with this. You would not want to depend on the database to provide the columns that are there. You would want to specifically mention the column that you would want the information. And probably the way I'm going to do that is select, then I'm going to type first name, last name, and favorite color. And once again from dbo.people, and now if I hit F5, okay, because of this comma here, right, I am getting the same information, people with color, and then there is this column called this value here is null, and it is appearing a little differently. We're going to talk about null in a short while. But then what if I only wanted to see the colors that are there in this particular database? So I'm going to come here and type give me all the favorite color from dbo.people. And now if I hit F5, it is getting me all the colors. Now I'm sure that some of these colors they're going to repeat, right? So I see yellow, green, I see white smoke, and I think I saw white smoke earlier as well. So the first record itself was white smoke, right? So is there a way using this select command that we can change that? And the keyword for that is called distinct. So I'm going to come here, type select, and type distinct, and type favorite color. Then I'm going to specify from where I want that, and that's the people table. And when I hit F5, notice that, okay, let me go ahead and run this query again. So when I run this query the first time, notice that it came back with 1001 rows. All right, that is because the last time around we added my record in the end, and then now if I run this query, it is coming back only with 144 rows or 144 entries. The reason is because of this distinct keyword, everything that was getting repeated, it has been eliminated. There is a null, and if you want to get rid of this as well, you can do that using another clause. So I'm going to just copy this and mention it here, paste it here again, and over here I'm going to put a where clause, and I'm going to say where the favorite color from our programming experience is not equal to null. Now, when I run this query, notice that it did not came back with any result. Why is that? I mean, not equal to null seems fine. Let's go ahead and try equal to null. And when I run this, it does not give me any result. The reason is null in queries, it is treated a little differently. It is a concept of set theory. It is comparing this particular thing to a set with no values in it, and that is why it is not working. So a syntax for comparing null value is not this. It is not, and then let me pump this up to all capital as well. Now when I run this, notice that from 144 we have dropped to 143, so that one record, one distinct null has been removed. Let's go ahead and see if I say is null, what it comes back with. So it's going to come back with exactly one row, and then just because it is coming back with one row, it doesn't mean that there is only one null entry. If I come here and say that, okay, give me the first name as well, and if I execute this query again and hit F5, it came back with 189 rows, and then these rows here, they did not mention their favorite colors. Make sense? So I'm going to move on, and we are going to look at the where clause a little more closely. So if I want to extract specific information, okay, so we already saw what attributes are, and then we saw that combination of attributes is a little interesting. But then when we looked at the people definition through this command, let's see one more time that in the last result, it said that there's a constraint. There's something called as primary key. Now, the specialty of primary key is that it ensures that a combination of these two fields, the last name and first name, what we pasted here, the combination of these two fields, it is going to restrict entry of uh, that combination only once, and then once it is um, once it is available in the system, it is not going to be reported. It is not going to be repeated again. I'm so sorry. So I'm going to come here and copy this. I'm going to come here and paste this again, and let me run this query one more time. So if I run this, okay, by the way, notice that this time there was no semicolon, and then semicolon doesn't is not required, but then it is a good practice to put it at the end of a logical query. You can run it without semicolon as well, but then I generally put it in all of my queries. So we saw that, let me put last name as well. When I run this query, I come back with this result. Now we saw that last name and first name combination makes it very unique. So let's go ahead and verify that. So in the where clause, I'm going to say that last name equal to this. I'll have to put it in single quote. SQL Server does not probably work with double quotes, right? Notice that it is giving you a syntax error. You will have to use, if you want to use string operations, you will have to put them in single quote. And then the keyword for having more than one filter is our words and not ampersand ampersand from our object-oriented programming or C-like syntax. So we're going to have to enter English and here, and the first name is Sarah. And now let me put my semicolon. And now if I hit F5, it came back exactly with one result. It is because that the first name and last name combination, it is a primary key. But then the third column here, favorite color, that is not a primary key, and we are definitely going to come back with more results if we change this part of the query from first name last name to favorite color and mention white smoke here. So now if I hit F5, we came back with 5 results. So there are 5 people who like the color white smoke. Make sense? Now you can try combinations of these. That I don't want to see all the information of these uh, all these columns. I would probably want to select only a few specific columns. That I would want to know the first name and last name of people who have us who have favorite color of white smoke. So when I enter that, there are only 2 columns that I'm seeing in the result set. Let's go ahead and do the same exercise for the car stock table that we have. So once again, I'm going to do select star because I don't know the columns at the moment, and then I'm going to say from dbo dot car stock, hit a semicolon, select, and hit F5, and it came back with at least 1000 rows. Okay, give me 1 second. Right now, if we run this, you're going to see that there are 1000 rows, and the color of these cars is blue and light blue and violet and tan. There are some nulls here as well, and there is a lot of repetition as well. So once again, with the distinct keyword, if I put it in front of color and say that from dbo.carstock, we are only going to see 21 rows because there are only 21 distinct color cars available in this particular database. With that, if so, the reason this database was created in this particular way was uh, there are people who have a favorite color, and we have cars that have a specific color. Now, one theory that we can make is people would want to buy colors of cars of their favorite color, and then that'll make us interested in identifying people who say like um, maroon color for their cars. So I'm going to come here and I would want to find out the first name and last name from the people database where favorite color is maroon. I'm just going to paste that here. And then I came back with at least 2 results. Tia and Tisha, they like the maroon color, and we know that if I create a different query and say that select say star from dbo.carstock and put a where clause to it and say color equal maroon, it's going to come back with at least 35 cars. Now, it is possible to select multiple queries and execute them together. If I make that selection and hit F5, I know that um, these two people, they are interested in these. They could be interested in these 35 cars. But then It would be nice if we don't have to run two separate queries and we can make them part of one single query and execute it together. And for that, there is something called as in databases terminologies, there is something called as join. To make a join, you instead of providing one from, there are two from that you provide. So let's go ahead and let's write that query. So in a joint, I'm going to put select star. Then I'm going to say mention name of all the tables that are there in the system. There's a people table, and the way you join is you mention the keyword join, and then you type dbo dot car stock. Now let me go ahead and run this query first. And if I hit F5, okay, I forgot mentioning something here. I want to say cross join. And now if I hit F5, right, it is still generating result. Look at this little message here, executing query, and then this green box, it is what it was in motion. Notice this count here, that it came back with 1 million rows. And then if you notice here on the result window, you're going to notice that this win number is the same for a lot of records. Now, if you remember, okay, probably I should show you one more type of query. It is not always that you would want to come back with data, right? Like like this one here. Sometimes you would want to know how many maroon cars are there in the system. And then for that, there's a special function that is available, and that function is called count. I don't know if I can mention count in this thing. Okay, the count function, it is it is like one of those few exception places where it is okay to put star. In general queries, you would want to avoid star, but then inside count, it is okay to mention star. When I come here and repeat this part of our query, it is saying that give me the count of cars from car stock where the color is maroon. And if I run this query, notice that the result is only one row, and then that row contains the count of exactly those cars. Let's do this one more time. If I run this query, I get 35 rows indicating all the details of all those cars that have color maroon. But if I run the count star, um, we are going to come back with count of this particular thing, and they're called as functions in SQL. These functions, they give you a different type of information. And with that, I'm going to take a quick diversion, and I'm going to say that databases, they have they answer only, the way they're built is they are for answering questions. And then those questions generally sound like this: tell me how many uh, people are there um, in our records, right? And this is where we ran the select star command. Tell me how many cars we have. Tell me, give me information about people. Okay, and it is going to give, it is the select star query. Tell me how many cars we have. It is the select count star query. There are specific questions that you would want to ask that are very limited to your domain, and then it is through that domain that you decide or build your databases. So when we see the data definition language part of our database section, we are going to see this thing in more detail. But then for now, let's continue with our example. The count star query for car stock, it gave us the result 1000. If I'm so sorry, not this, it gave us 1000 results, and it is the same for the people table as well. Select count star from dbo dot people, and if I hit F5 here, it came back with 1000 as well. So our people table also has 1000 rows, and car stock table also has 1000 rows. Now when we do join, it came back with a million rows. If I run it again, it's going to take a while. The reason it came back with those million rows is because there are 1,000 people and there are 1,000 cars. So 1,000 into 1,000 is 1 million. This is the entire people table. On the left, they are all listing all the information from the car table because it's a cross join. And then if I scroll down quickly to spot number, say 1,000, God, I'm already at 81,000. Right, you're going to see that for each record, you're going to see all those 1,000 cars mapped. So this is a very inefficient way of multiplying or looking at a join of two tables. You would want to use a different kind of join, and it is called the left join. The way it is done is it's a two-step clause. One is you're going to mention the join keyword, and the second clause is you're going to mention the on keyword. On the on keyword, you're going to say that where dbo dot people dot favorite color, it is equal to dbo dot car stock dot color. And when I run this query now and hit F5, it came back with 5,398 results, and it is every time it is very unique. When the favorite color matches with the color of the car, it keeps only those results and it removes everything else. Okay, so with that, let's take a quick break. When we come back, we're going to resume our second part of the session. Alright, so before we went on break, we saw that the car stock has 1000 rows in it, people have 1000 rows in it, and we were interested in finding people with a favorite color for which we have a car in the stock available with us. So the way to do that is you can run two separate queries and manually compare, or a better way is that you take a join. There are two joins, one is cross join and this one is the left join. The reason it is called left join is because it is picking up everything on the left hand side of the statement and it is selecting the ones that are there on the right. There's a different query. Left, you don't have to mention left here, but then you can mention left join if you want to be specific. There is another option which is called the right join, and when I run that query, notice how the output will change. I'm gonna leave this join, and the next one I'm gonna call right join, and then let's see how that affects the output. So when I do that, I came back with a different number. It is picking up all the cars from this side where it is matching with the people name. So it's a tricky concept. If you compare the two results on a smaller database, you would understand that the first time we were trying to find out cars with all the people that are there in the system. This time around, we are saying that for all the cars that we have, give us uh, which people would be interested in those. Okay, so with that, we can bring the select part to a conclusion. There are multiple type of select that you can do. Starting from people, you can use functions like count and find out group, tug that information together and then come back as one result. And then you can also join two different table and try to find out information about the relation between these two tables. With that, let's move on to the next part. I'm going to start a new query. We are already in demo database, so I don't have to type this, but let's just go ahead and run that. So far, we were only reading data from the databases, but we can also insert values into these tables. Now, this into keyword is optional. If you don't want to write it, it's okay. I generally prefer writing it. And then if I select dbo.people, there is another clause that I can enter. It's called values. And for inserting these values, I'll have to provide it in a specific order. And then if you are ever confused about that order, uh, we can always fall back on the built-in stored procedure sp help and select people here. And then it is exactly in this order that you will have to provide those values. So let's go ahead. Let me enter my name here. And my favorite color is red, for example. I'm going to execute this query and notice that there is one row affected. Now if I come back and do select star from tpo.people where first name equals Zia, and if I run this, it's going to come back with the information that we inserted. But then it is not always necessary that you will always know the color name. So if assume that there is another person Zia2 and then there is no favorite color for that person, or you don't want to enter the color right now, so you can enter value null here and hit F5. Notice that it inserted one row again. Let's go ahead and see what that information looks like. So when we provide a null value in the query, it gets inserted as null. But what if I enter a third record, and for that third record, I do not provide the value at all? And if I hit F5 this time, it is complaining that the column name or number supplied value does not match the table structure. And then if you run into such issues ever, you have an option of selecting the column names that you would want to insert values for. So besides next to people, I'm going to mention column name in the order in which I want to insert, and I'm going to hit F5 again. And it is saying that the primary key is getting violated because ZR2 is already present. I'm so sorry. It should have been some other name. And then it inserted that thing. Probably without first name and last name also it would have worked because it wanted at least the primary key columns to be completed. With this entered, now if I come here and select this, notice that the favorite color was willow blue. Right? You guys remember seeing this color before? We have not provided the color name column. We have not inserted any value. When we provided null, we got the result null. But then when we didn't provide any value, it came back with willow blue. And the reason for that is in this particular output. If I scroll down, if I scroll all the way down and come back here, notice that willow blue is mentioned here and the constraint name is default. So if I don't provide favorite color, it is going to default to that willow blue color combination. Make sense? So we have seen multiple combinations of insert query that you just mentioned the table name, and in a specific order that comes here, you provide the values. The second is you can insert null values, or if you leave a column empty, if you don't mention the column at all, it is going to pick up the default value if you have specified it while you were creating the table. And then you can also control the order in which you can insert this information. So if I move this around, and this is the recommended way of doing it, if I provide the value like this, now, excuse me, now if I mention ZR4 and okay, I will have to switch these two things as well, but let's go ahead and live with, let's go ahead and just run this. Now if I come and select star, and this time I cannot mention the first name as ZR4, I'll have to mention Khan, and notice that it came back first name Khan as one result. But then if I say change this to last name and run this again, it is going to come back with 4 results. I didn't know that there was another entry with this name. Alright, but then ZR, ZR2, ZR3, these entries, they are coming and the last name is matching. Okay, with this, another type of query that I would want to show you is you don't always have to insert using the values clause. There are other combinations as well using which uh, you can insert values. But then before that, let me go ahead and show you another insert clause. Once you have this order identified for people, you don't always have to enter like one row at a time. You can enter multiple rows and separate them all with commas. Right? They have to go in the order of first name and last name. Let me go ahead and fix this order as well. And let me change this to the 5. Okay. Now if I run this query, notice the output that is saying that 3 rows affected because we inserted 3 values. So if you want to insert multiple values, after the values clause, start providing values in parentheses and separate them with a comma. And it's going to insert multiple values for you. Now let's go ahead and run this query one more time and find out how many people share my last name. And there are a whole bunch of them. There are like 7. There is a interesting way of running the insert query, and let me show that to you. It's called select star, and then instead of from, I'm going to use the keyword into. Now with this, I have to provide a name. I'm choosing to provide it in square brackets. It is optional. I'm going to call it all the Khans, and from this point onward, I'm going to continue with my regular query, like from the people table where the last name is Khan. Now if I select this and run this query, notice that there are 7 rows affected, which was the exact output of this particular selection as well. But now I can go ahead and run a different query. I'm going to call it select star, and this time I'm going to say from all the Hans, notice that it is available as a table. And if I hit F5, I'm going to come back with those 7 results. And then the 7 results of the people table, they are still present here, right? So we have not moved those records from this particular table. Those records are still there. And then we have created a new table with this particular information, right? Now, if I want to add more information to this, I can go ahead and run this information, and I'm going to say where last name is Zia 4, I guess, if I remember correctly. And then notice the error message that I'm seeing, that there already is a name with that particular, there's already a table with that particular name present in our database. So select star or select into this query combination. It always requires a new table. And then if that table is already present, it is not going to work. One more query that probably I should show you at this point is exec. I'm going to type sp underscore help, and I'm going to show this table. So this table only has values, and the constraints that we had in the people table, they have been removed. So this table is created without any constraint. There are ways you can modify this table later on using the DDL language, but the difference between people and all the Hans table is that it does not have any of those constraints. Okay, it is just a projection of the people table. So if I still want to go ahead and insert value into this table, I'll have to change the query format, and the way we embedded into inside the select query, we can do the other way around as well. So we're going to do it a little differently this time. We're going to say insert into all the Hans, and then you select values, uh, and then call it select star. I can put star here because the order of the column is same. And this time around, I'm going to say from tbo.people, and I'm going to say where last name equal to, I'll probably say favorite color is smoke white. One thing that I should tell you at this point is SQL is case insensitive, and if I put smoke white in any case combination, it is going to pick up everything. So I'm adding all the people. Let's go ahead and run this query first. Smoke white, smoke white, white smoke. It's the other way around. I'm so sorry. Okay. Now if I run this query, there are 5 people with the favorite color white smoke, and if I pair this query with the insert into all Hans, and if I run this query, notice that there are 5 rows affected. And now if I come to select star from and run this query, um, okay, I'm so sorry. I wanted to run this. So when I run this, I see that there are people who are not Khan, but then their favorite color is white smoke, and these are the 5 rows that we inserted just now through this last query of ours. Insert it to all the Khans, and then you put a select down below. So insert have multiple syntaxes. We probably covered all of them. The simple insert, one with columns, one with the select query, and one with the insert query. Okay, one with the insert query. So with that, let's move on to the last section for today, and we're going to talk about the update query. And then update gets a little tricky because once you update, you are permanently losing the previous value of that particular table. So I'm not going to perform the entire operation on the people table that we had. I'm going to copy it to a backup table, and I'm going to call it, say, people2 or people backup. So I'm going to use the into syntax. I'm going to say select star into, I can call it people2. I'm going to say from tbo dot people, and with a semicolon, if I hit F5, it has copied all the 1007 rows, and we now have a backup. Now the reason I did that is because I wanted to show you a very dangerous way of running the update command. The update command is going to modify value of a particular column. If I type dbo.people2 here, to update a column, I'll have to use a keyword set and mention the column name here. So the favorite color column, and then let's say I want to update it to green. Okay. If I select this and if I hit F5, let's before that let's go ahead and see what we have inside people2. Select star from people2, and if I hit F5, I get 1007 rows, and these people have these colors. Like Vicky likes royal blue, and some people do not have a color. There are nulls on. I'm going to remember this row number 21. 21 has a null in it. Now if I come here and execute the update query and hit F5, notice that 1007 rows are affected, which means that every row in this particular table is affected, and now everything is green, right? So this is a dangerous way of running an update query, and when you want to update something, you want to be extremely careful that you are always running the update query with a filter clause. I am sure there is a setting somewhere in SQL Server Management Studio which is going to not let you run a set command or an update command without the where clause. So there are settings that you can do. I don't know if it is there in SSMS. I'm hoping that it should be there. Um, it is. I've seen definitely it in other editors for MySQL. I can come here and I can say where first name is Sarah, and I'm going to change it back to white smoke. And now if I run this, notice that unlike the previous run, it is only one row that is affected this time, right? And if I come and run this, select star, notice that the color has been updated. Now, in cases where you have you wanted to run an update query, it is always recommended that you back up it into a new table using the select into query syntax, and it is going to create a new table for you without any of the constraint. And then if you make any mistake, you can definitely fix that through running different queries. So let's see if we have different ways of doing that. I know that it is not always the primary key or one element that you have to enter. I know that there are multiple Khan in this particular table. So let's go ahead and see how many people in people2 table. Select star from dbo.people where last name equal to Khan, and when I run this, I come back with at least 7 rows. An update query would not necessarily update only one record. We can go ahead and update all these records at the same time. So the number of rows with which where clause comes back are the elements that are going to get updated. So if I now run this query again, all the 7 rows, they are affected and they are all uh, on the color white smoke now. Now, let's go ahead, and we know that we broke the people2 table because everybody has a green color, but there is a way of fixing that, and that is going to be our last query for today. We're going to start with an update syntax because we want to fix the favorite color column. So I'm going to write update dbo.people2, and there is a special syntax that we're going to use this time. Within a query, when you put parentheses, okay, before that, let's go ahead and put favorite set favorite color, and then for this set favorite color we would want to provide color from the original people table. And then when when a query is combination of two such different sounding queries, you start using parentheses, and this is called a subquery. And inside the subquery you are simply going to select favorite color, but this time you are not going to use people. people2 database, you're going to use the people database. So this is where it is going to pick up all the favorite color in the same order, and it is going to assign it to this particular column here. But before we do that, we are going to use a where clause, and the where clause is going to make sure that their primary keys match. And the primary key columns that we had were the first name and last name. So we're going to make sure that people dot first name matches people2 dot first name, and we'll have to pair it with the last name as well, and it has to be people dot last name equal to dbo dot people2 dot last name. So with this clause, the result that are going to come back, they will definitely come back with the people name matching. And with those matching names, it is going to pick up the favorite color, and it is going to assign the favorite color to favorite color column of people2 table. So now if I run this and hit F5, there are 1007 rows that are affected. And now if I run select star from dbo dot people2, notice that we have restored the table. So there will be situations where you run into such issues, and using queries and subqueries like this, you can update selected columns and apply correct level of filtering to those columns. All right. So with that, we're going to jump to the last section for today, and that is the delete query. And then delete is pretty straightforward. Once again, we are not going to work on our main people database. We are going to use, we're going to spin up a new table using the select into format, and I'm going to say select star into people3, and then I'm going to lean on to the people database. Once I hit F5, a new table is created, people3, and then you can also see them here in the database. If I come to DemoDB and look at tables, I'll probably have to refresh. Once you refresh this, DemoDB tables, and then this people2, and people3 is the latest addition to the family, right? When I run this query, so the delete is pretty straightforward. You use the delete keyword, and then you mention, okay, and then you mention the table name here like this. But then if I execute this query, once again, notice the output that we're going to see. Let me see if I can delete this. Okay, I thought I'll be able to clear it up. Okay, if I select this and hit F5, 1007 rows are affected. I should have run the select star query before I ran that query, but let's do that now. So there's people3, select star from people3, and then it did not came back with any result. It did not come back with any result because delete people3, it deleted all the rows. So it might appear initially that if you run delete and provide a table name, it is going to delete the table from here. That is not how it works. If I refresh, notice that people3 is still here. So this delete is different than removing the table itself. All right. So once again, I'm going to create a new table because I cannot do select star into people4 now. Let's go ahead and do that. If I hit refresh here, now we're going to see people4 table. And over here, you can once again provide the same filter clauses that we have already looked at. So I'm going to say delete people4 where last name equal Khan, and if I hit F5, it is going to delete those 7 rows that we had inserted, and probably this is pretty much it that probably we have for delete. You can once again use these subqueries here like this and say that select favorite color from the people table, where people dot first name equal to people 4 dot first name and people dot last name equal to people 4 dot last name. So with this, it is going to come back with a list of favorite color. If I run this query, there's a syntax error because I entered this twice, and I'm not sure what it is complaining about. People for first name could not be bound. Select people for. Okay, so probably subqueries are not going to work in this case, where favorite, oh, come on, color equal this. All right. When I do this, I'm not sure of the result, but let's see how many. Okay, it'll need people 4 and then people 4 is not there. Let's directly run this query, and there are like 812 rows that got deleted. So on the first name matching, it picked up the favorite color and it deleted those records. Right. So there are ways you can combine. You can put a subquery and delete clause as well, and start removing the columns from start removing rows with matching criteria from your database. So just to summarize, we have seen the DML today. Uh, we have seen the select query. There are multiple ways of selecting. You can use select star. You can provide select and column name. You can select from and then provide a filter criteria using the where clause, and it is going to come back with shorter result. When there are multiple table involved, you can use the join keyword. And the left join is a way which is going to prefer result from the left side of the statement. The left table is going to come back with those results. With the right join, there is a different query that you were asking, different question that you were asking, and it is going to pick up the right side of it. Insert is for inserting values into table. You can insert one value, you can insert multiple values. You can change the order in which you are providing those values by providing the column names, and then you can combine the select and insert query. Select into is going to have an insert like effect. Insert and then select in the values clause is going to pick up selected values and insert into a different table. So you can have a combination of those. You can create tables at runtime. They'll come in handy when you want to process things or take join at a shorter rate. The update query is going to update one row or all the row depending on the filter criteria that match. It's a difficult query. I would recommend taking a backup before you run update query, and delete query is going to delete rows and not the tables. All right, so this is a quick summary of SQL. Everything that we did in SQL Server here, it is also going to work in MySQL. If you can run MySQL using Docker, you will not have to go through a lot of installation. But if you are willing to do that installation, you don't require Docker right now. You can install Microsoft SQL Server, the Express Edition, and then SQL Server Management Studio, and then connect to the SQL Server Studio. All right. So with that, we can bring our today's session to a conclusion. And if you guys have any question, I'm open to it now.